Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. In today's presentation, I'll be talking about a tool which is called as StatCraft P. What is StatCraft P? StatCraft P is a web-based solution for data science with Python. The topic of discussion today will revolve around quality control in steel plate manufacturing industry. I repeat, quality control in steel plate manufacturing industry using machine learning. What is the business problem that we have? Consider a factory that produces steel plate in the final step of the production system. Our aim is to maximize the efficiency of the production system, trying to identify the possible types of steel plate faults. There are 7 types of faults in the steel plate which we are trying to detect. In this case study, we will be using machine learning techniques for quality control in a standard production unit in the form of a classification problem. What about the data set that we have? We have data containing various parameters of the steel plate like luminosity, perimeter, edge, thickness, area, type of steel, so on and so forth. I have 27 independent variables in my data set, and there are 7 different types of faults. What are the 7 faults that we have? Some of the faults that I have listed are scratch, stains, pastry, dirtiness, bumps, and other faults. I wish to show you this particular data set in the spreadsheet. So this is the data set that we have. This is how the data set looks like. We have some variables like minimum, maximum, ymin, ymax, pixel areas, perimeter related stuff. We have luminosity, length of the conveyor, steel plate thickness, edge index, so on and so forth. I also have 3 very important variables. That is the type of steel plate, whether it belongs to the 300 variety or does it belong to the 400 category of steel plate. I have the last variable which talks about the fault that is present on the steel plate. It could be pastry, it could be other types of faults as well, like other faults or bumps or any of these faults that we see on a steel plate. What is the sample size that I have in the data set? I have a sample size of 1,942 cases. Let me go back to the PowerPoint presentation now. One of the first things that we do, even before we jump into machine learning, would be to perform EDA, or what is called as exploratory data analysis. What is the objective that we have? The objective here is to find the frequency distribution of the type of fault present in the final production system. The technique that we will be using here is called as a count plot. Let me show you how the count plot works in StatCraft. So this page is the StatCraft main page, and you have already seen this particular data set. I'm in the data editor window. I can click on the analysis tab, and as I scroll down, you'll see the option which is called as graphics. Let me click on the graphics menu. Here you see different options. One of the options that is present is count plot. To the left side, you see all the variables that are listed in the canvas, and under the variable list, we have what is called as faults. Let me click on the option OK. StatCraft takes a couple of minutes to run the output. This is the output of the count plot. We can see the library that Python has used at the backend. We can see what are the codes that have been used to generate this particular output. And this is the output of the analysis that I did. Now, to interpret this graph better, what I'll do is I'll take you back to the PowerPoint presentation. I've taken the same output and pasted here. What is the inference that we can draw from this particular graph? Mainly, we see other faults, bumps, and K type of scratch dominating the list of faults that are present on the steel plate. So one of the important findings from the count plot is that we observe that fault number 3, that is other faults, they are the maximum. After that, we have faults number 0 and 2, that is scratch and pastry. They are more as compared to the rest of the faults. Now, one of the questions here is, what is the benefit that we get by doing a count plot? If you read this explanation, the manufacturing team will get an idea that the faults like other faults, scratch, pastry type are maximum, and therefore they can now focus on the corresponding machines to reduce these faults and increase the quality of the steel plates. This is one of the benefits from the earlier plots that we have been able to produce. Let me go further. In this slide, we are talking about inferential statistical analysis. This is very, very important, especially for those people who are interested in hypothesis testing and such things. What is the objective that we have set for ourselves? Here, the objective is to check if there is any relationship between the steel type and the type of fault present in the steel plate. We have different types of steel, like the 300 variety of steel or the 400 type of steel. And we are interested in finding out if there is a relationship between the steel type and the type of fault present on the steel plate. What is the technique that we have used to answer this particular objective? We have used a statistical technique, which is called as chi-square test of association. To perform the chi-square test of association, I will take you to StatCraft. But for those people who are new to statistics and chi-square, let me just quickly explain what this test does. This test is a simple test that we use in statistics, and the goal of chi-square is to find if there is a relationship between two categorical variables. Remember, steel type is a categorical variable. The variable faults is also a categorical variable. We are interested in finding out the relationship between these two categorical variables. How do we perform the chi-square? To see how the chi-square test is done, let me take you to StatCraft. This is the analysis tab. I will choose the option compare groups. I have a lot of tests here, but I will choose the option cross tabs. As you can see here, I have already chosen the option type of steel, but I can remove this particular option 300 category, and I can choose the 400 variety instead. And along the column, I will choose the option fault. Then click on the option OK. In a few moments, StatCraft will be able to produce the output. You see all the tables that StatCraft is running at the backend. If you want, you can pull out this code and put this in Python and rerun the analysis. You'll be able to get the same output. This is the earlier code, but the output for cross tab starts now. These are the libraries. This is the data frame. If we scroll down, you can see the contingency table, the column proportion, and the row proportion. What I have done is I have copied and pasted the same output in the PowerPoint. Let me explain the output from the PowerPoint. As you can see here, we have both the row proportion table as well as the column proportion table. I've highlighted some of the eye-catching numbers here, and we can also see the third table, which is the chi-square table. This chi-square table is very, very important. Chi-square table and the p-value is also revealed here. Now, from the row proportion table, what do we conclude? If you look at the explanation here, from the row proportion table, we conclude that the proportion of pastries and other faults is very, very high when we manufacture a 400 variety of steel plate. This is very, very important. Similarly, when I look at the chi-square statistic, the p-value is less. It is less than 0.05. I'm looking at this particular value here. It is 8.15 into 10 power minus 141, which is a very, very small number. we compare this p-value with level of significance, and if this number is smaller than 0.05, we conclude by saying that there is a relationship between steel type and faults. I now move on to a multivariate technique. So far, we were talking about bivariate analysis. Chi-square is used to find out the relationship between two variables. What happens when we have a lot of variables in our data set? We can do a technique, we can perform a technique which is called as feature extraction. When I have 20 or 30 variables, I don't need to look at all 20 or 30 variables. I can squeeze these variables and extract only 2 or 3 most important variables which drive the type of fault on the steel plate that we were talking about. For this, we use a technique which is called as feature extraction to show how we can perform the feature extraction in StatCraft. Let me go back to StatCraft. This is my StatCraft page. I can click on the analysis tab. You see a whole lot of options. Please choose the option feature selection. As you scroll down, you see the option classifier. Now, the dependent variable I will be using here is the fault type. I've already spoken about the 7 different types of faults, and I have listed here all the independent variables that I want to use for analysis. It has a lot of variables corresponding to steel plate like luminosity, perimeter, edge, thickness, area, and the type of steel, right? So these are the variables that I have in the independent list. Now I will be clicking on the option OK. Let me wait for a couple of seconds so that StatCraft quickly comes back with the answer. This is the old output that you're seeing. That is the crosstab output. Let me scroll down. Again, this is the old output. We have seen some of these things. Now, this is the output that StatCraft has produced to run a feature selection classifier. Some of the libraries that it has used as the used at the backend is being displayed. Let me scroll down. You see all the codes. You can see the feature importance. Now, this is very, very important because to identify which are the key drivers of fault, all that I need to do is look at the importance, look at the variable importance, and those variables which are very, very important, I can only focus on those variables to control the amount of fault. I will take you back to the PowerPoint to show you the output of feature extraction. You can see here, this is the output for the relative importance of the different variables. I have listed all the variables here. You can see steel plate thickness is the most important driver of the fault type on steel plate. It accounts for 9% of the type of fault. Very, very important. The second important variable is length of the conveyor. Then we have Xmin as well as Xmax. Then you have minimum of the luminosity. So these are the top 5 drivers which influence the steel plate fault type. Now, how is this beneficial? This is important because there is a simple rule in statistics called as the 80-20 or the Pareto principle. What is this Pareto principle all about? Pareto principle talks about 80-20. 80-20 simply means by focusing on 20% of the reasons, you will be able to solve 80% of the problems. By focusing on some of these variables like steel plate thickness, you can see here steel plate thickness, length of conveyor, and X minimum, I will be able to bring down the type of fault on the steel plate to the extent of 25%. Let me move on to the next slide. This is the output of StatCraft. As I was just saying, length of conveyor accounts for 9%, steel plate thickness accounts for 8%, and edge variable accounts for 8%. So some of the important drivers of fault are being listed here. Proceeding further, we can now move on to predictive analysis. What is the objective that we have in this data set? One of the main objectives that we have here is to maximize the efficiency of the entire production system using decision tree classifier model. So the technique that I will be using here is called as the decision tree classifier. We will be using this to predict the possible type of fault present in the steel plate. As I mentioned, the techniques would be twofold. Firstly, let us try the decision tree classifier. Then we will run the random forest classifier, and we will be comparing the results of the decision tree classifier with that of the random forest classifier. Whichever gives us higher percentage of accuracy, we will freeze on that particular technique. To run the decision tree classifier, what I will do is I will take you back to StatCraft. This is the output of the earlier analysis. I can click on the right-hand side, my apologies, left-hand side top corner. And here you see the option which is called as machine learning. I will choose the third option, which you see here, which is called as decision tree classifier. In decision tree classifier, in the dependent list, I have chosen the variable fault. The different variables which can influence fault type, I have chosen and listed along the independent list. You can change the parameters and the different options here. You can also look at the plot here. I will simply click on OK to get the output of the decision tree. StatCraft is running the analysis. It should not take it a long time to run the analysis. Looks like the output is ready. You can see here, this is the code for the decision tree classifier, which we have run at the backend. Very, very important. The decision tree classifier indicates the feature importance. As before, decision tree is very, very useful in pinpoint. It helps us pinpoint which are those factors which mainly cause failure. By looking at some of this output here, I will be able to take a call as to which are the critical parameters that I need to focus on to reduce the faults on the steel plate. You can see the confusion matrix corresponding to the training data set. You can also see the confusion matrix corresponding to the test data set. To interpret this better, what I will be doing is I will take you back to the PowerPoint. So this is the output of the decision tree. We can see important accuracy metrics like precision, recall, F1 statistic, and these metrics have been given for each of the 7 types of the faults. The overall accuracy is also listed here as 71%, which is quite good. So when we run the decision tree, what do we observe? We observe that the decision tree model gives us a 71% accuracy for detecting the fault present in the steel plate. Let's now look at the test data set. You see the same metrics like precision, recall, and F1 score for the 7 different types of fault. And the overall accuracy is also being shown as 76%, which is quite good. The number 71% in the training data set and 76% in the test data set tells us that this model that we have built is generalizable, right? So this is the output that we see for decision tree. The first output corresponds to the decision tree. The second output corresponds to the random forest. We have not run a random forest classifier to interpret this particular output. Let me show you how the random forest algorithm works. I will again go back to StatCraft, click on Analysis tab, Machine Learning. Let me scroll down, and as I scroll down, I will choose the option Random Forest Classifier. This is the dependent variable, and all the variables that we had earlier, I'm choosing as the independent variable. Let me choose the option OK. The output is ready. So you can see the report here. This is the output of random forest. This is the test result, and we are able to get an accuracy of 76% in the random forest classifier. Let me take you back to the PowerPoint. This is the output of the objective 3 using a random forest classifier. We are getting 76.9, which is not bad at all. The random forest model gives us 77% accuracy for detecting faults, but the decision tree model gives us 71% accuracy. So by running these two algorithms, we can compare the overall percentage of accuracy. Clearly, random forest is better than the decision tree. Now, what are some of the benefits of objective 3? Random forest gives a better performing model, and using random forest, we can identify the faulty items. The faulty items, once we predict the faulty items, we can save the model for future use. With this, I have come to the end of today's presentation. I request you to subscribe to my channel, and thank you very much for watching today's presentation.